Okay, so at the bottom of the page, there's a couple different CAD, computer assisted design sites. One of them is super easy to use. The other one a little more complex, or actually a lot more complex. We're going to go to the one that is really easy to use, and it's called Tinkercad. Okay, and Tinkercad is just a, I mean, if Tinkercad didn't exist, it would be extremely challenging to get students to be able to 3D print things with ease. Okay, because this site, which is actually a web application, is just gold. So and a lot of things are amazing about it. So I'm going to talk it up a little bit as I sign in here. Okay, so this is Tinkercad, and just one of the things that makes Tinkercad such a cool thing for students starting out with computer assisted design is that, you know, and you don't have to necessarily log in right now or make an account right now, but there's this up at the top here, there's a link to learn. And actually, when you create a new account, it takes you right to the lessons page. And Tinkercad has a ton of lessons in it. So when I have kids starting out with Tinkercad, after they make this keychain or a keychain that looks something like this, I send them through the tutorials. Okay. I do it after because I want them to actually have something in their hand that they made first to kind of set the hook. Because if you tell a kid, yeah, this is your introduction to 3D printing, go ahead and go through these, 14, 17, 26 lessons, and then you'll be able to print something. It's not as cool as having them strap a keychain onto their backpack and then jump into the lessons. So I just kind of take them through step by step the how to make that keychain first. But the lessons are very basic and basically teach kids how to use the tools. I will say that, and this is you can use this on a Chromebook, so kids can get on the Chromebooks. I will say that if you're gonna be using CAD software, that you're gonna want to order some mice, because the trackpads on the Chromebooks and the trackpads even on my laptop, it's kind of not. It doesn't really function as well as using a mouse.
You're talking about ordering mice and filament and stuff. Is there a budget for that?
Yeah, I'm sure there is. Yeah, I mean, this is I think the 3D printing is kind of housed under CTE, so it's basically we have truckloads of CTE money that aren't being spent yet. So I don't know, I don't know where our budgeting is at the end of the year here, but I would say that anytime you wanted to order mice, I think have to go through normal channels. But the filament itself, or any parts like that extruder, I would contact Alex or Marisol Rucha and find out and order it through them, using CTE funds. But yeah, so the lessons are really super good. And just to kind of give you an example, I'm going to go through this wrench lesson, and this lesson is on creating holes. So just to give you an example of what it looks like to go through a lesson, it gives you really step by step that you start by dragging a brown hexagonal prism shape located in the shape list. So over here on the right hand side of your user interface, you have all these different elements here. And when I go into the geometrics here, I have all these shapes. And so some of this is kind of counterintuitive to the way we normally do stuff. And so it's basically showing me here, grab a brown hexagonal prism. So I got to come over here, find this hexagonal prism, and I drag this onto my work plane here. And it gives me this just little kind of ghost shape here that I can kind of plop it onto. And now so it gives me, it makes it pretty easy for me not to mess this up. And the idea behind creating holes in any object is you have to bring in a shape, select it, and then make it a hole. So when I click on the hole here, you can see that it has kind of, it's created an invisible hexagonal prism. And then I select both the shape that I'm putting the hole in and that hole shape. I select them both together, and then I group them together. And by grouping them together now, I've created a hexagonal shaped hole into that wrench object. Right? So let's say that, just as an example, let's say I wanted to create a cylinder like this that had a cylindrical hole down the middle of it. I would drag out another cylinder. I would shrink it down. I would make it longer. I would pull it into the middle of that. I would make sure it was selected, and I would create a hole out of it, and then I would group them together. Right? And now I have this cylinder that has a hole through it. Okay? So that's the idea. You never press the delete button to make a hole. You know what I mean? You have to basically take a solid shape and then another shape and make a hole out of it and group them together. Right? If I never did that, let's say that, if I want to make a cylinder with see, it's such a pain in the ass. I wish I would have brought a mouse with me. If I wanted to create a cylinder with like an axle sticking out of it, right? I would just group these two together now. Now I have this shape, which is, this piston. It's like a piston. It's a shape. It's a cylinder with a smaller cylinder coming out of it. You know what I mean? So this. Oh, cool. Thanks, man. This is how you join shapes. Is by grouping them together. Okay, so whatever shapes you bring together and whatever shapes and holes you bring together, you have to group them in order to combine them.
And did I see that all the measurements are in millimeters?
They are. Well, they default to millimeters. And so yeah, that's how and so if you're looking at a project that you want to do involving mathematics, right? So you're really dealing with geometry here, and you're dealing with measurement, and now you're talking about integrated mathematics. You're actually integrating mathematics into something, and it's not it's not the wannabe context of Carnegie. What, am I speaking blasphemy? Is anyone going to chop me down for ragging on Carnegie math? I don't even touch it, but I see the frustrations. But you're actually talking about truly integrating mathematics into something practical. Okay, yeah. So you're talking about a lot of measurement and reduction and things like that. So let's get rid of you. So these lessons are kind of take you step by step and really teach you quite a bit as you're as you go through them one at a time. Sorry, I want to pair up with Andrew's mouse here. That sounded not right. There we go. Okay, awesome. Yeah, so when you use a mouse, which I couldn't really do on my trackpad, you're able to fine-tune stuff. But if you right click and move, you can look around and underneath. If you use your wheel, you can zoom in and zoom out. So it's using a mouse is just a whole lot more functional than not.
You can do it with 2 fingers on the pad.
It's just yeah, it's not really. So you can see under here you've got, so if I look really deeply here, if I'm working on something, I can see that I didn't really place my hexagonal prism in the right place because I have these 2 little arms here. So then I can undo the grouping and move that out some, regroup them, and now I get this kind of underneath view here, and now I've got the proper placement for it. So there's, just, you've got shapes, and so Andrew, you brought up letters. They've got all the different letters and numbers, and they've got a few symbols as well. So, anytime you wanted to create, so when students are creating a keychain, basically the basic simple deal here is they bring out a box, they reduce it to 3 millimeters, they stretch it out, and they bring their letters in. So now what probably happened is, and if I look at this from this angle, I can see that the letter is raised. Okay, so I can make a keychain with raised letters. If I were to click on that letter and reduce its height, or actually, if I were to lift it up 1 millimeter off of the bottom, and I created a hole out of it and grouped them, I could make an embossed keychain. Okay, if I left it, oops, wrong one. If I left it down at here and I brought it up and I joined them or grouped them, I could make a keychain that had the letters cut out. So there's a lot of different, aesthetically, there's a lot of different ways you could go with it. But you drop those letters in, and you can make a very quick and.
Can you tilt the letters to stand them up too?
Sure. If I click it here and raise them up, right? There's all kinds of different ways that you can design this stuff. Okay, but most likely, you were saying that the letters popped off of a model that was on a that was on a backing, and sometimes that'll happen when the kids design. See, we deal with levels of degrees here too, which is cool. When the kids design, if you place the letter like right on top of the base, so it's just like sitting on top of it. Sometimes or any shape on top of any that's connected to any other shape, if it's just barely touching or setting right on top of or right next to, instead of being like integrated into it, a lot of times when you send it into the MakerBot software and it prints it up, it sees it as just barely connected. And that's when the stuff can pop off. So when kids make their keychain, and then I have them bring in a torus to be their come on back, buddy. To be their keychain connector there. A lot of times what they'll do, and I'm just trying to get out of there, is put it right on the edge,
It doesn't connect.
and it doesn't connect enough, and that'll pop off. So, you know, I have them really kind of bury it in there. Okay, and then group them together. So, and you know, so and you can definitely put something off center. So those letters and that torus are all off center. But if I select them all and I come up here to adjust and align, it gives me alignment tools. So if I click that middle spot there, it'll line them all up in order. So when they're creating their keychains, come on, drop. Look at this. It doesn't want to let me write momentum. Oh, okay. That's why I'm still in my alignment tool. I guess I can only do moment here. Okay. Yeah, if you run out of space, you can always extend your piece. So there we go. We have a momentous keychain. And so when I grab all this now and I use my alignment tool and boom, I align it all together. Okay, it doesn't align them, you know, I have to make them space-wise. They don't have a tool that will allow you to space them well, but that's kind of my job. Although I know all of our momentum is kind of awkward, right? I shorten that up. One last moment, make sure that it's aligned. What happens if I hit this one? They all align to that spot, which I don't want. Okay, and then when I'm all done, I group them all together. And that creates one solid piece. Oh, I was looking for the export button, but this is I'm still in the lesson, so it's not going to let me do that. So let me just go into a design. So let's say, yeah, during, let's say you built a star box. So this is kind of the same idea here, is that, you know, it has a star shape here. We hollowed it out, made it a hollow space, and then created a box lid out of it. So they created boxes. Some kids did hearts, other kids did stars, some kids did squares, square boxes, all that. So, but then under here under design, you just download it for 3D printing, and you download it as an STL file, and it pops it right into your downloads. And that's the workflow in Tinkercad. So my first suggestion to you, as far as learning how to design stuff, is to get into Tinkercad yourself and go through all those lessons. You know, and really kind of get to know and be comfortable with, because I guarantee you kids will be way more comfortable with it and they'll catch on to it way more quickly than we will. They just do. They just knock it out. So let's then take a look at the MakerBot software. It's called MakerBot Desktop. And so getting into the MakerBot Desktop, it'll open up on a page called, and this they have tabs up here on the top, and the first tab that it opens onto is Explore. And so this is the fun stuff. This is what MakerBot calls the Thingiverse, and the Thingiverse is just full of things that people have 3D printed. Okay, so you can come over here to Explore, You can look at things, and then, these are all the newest ones, but if you go down to kind of popular ones and you start looking at the different things that people have made, you start looking at some pretty cool stuff. So one of the things that we made, where we made a few of these whistles that someone designed. And yeah, so that whistle's over here. And I mean, it's a single print, and I'm not really sure how it works. We want to half print it and then kind of reverse engineer it. But I mean, that was just a little blow, but it's super loud. So this is like just a kind of a practical object that someone built and put into the this Thingiverse. So if the one cool thing about this, is that kids find stuff that they want to print. So this is where we found Darth Buddha. We didn't design that, right? A lot of this stuff is designed using either like 3D molding software, where you're not using shapes, but you're actually molding stuff. And there's also 3D scanners. So I think the MakerBot one's like $700, where you can put an object on the scanner and it will basically scan all of it.
Ron, you purchased a scanner recently?
Yeah. Have you used it yet? Does it work well? Okay.
I mean, it gives you definitely basic.
Mm-hmm.
Getting to export into Tinkercad is a little problematic. There's a lot of holes.
Right.
If you have something like this CAT scan, you scan specifically lighting, it has holes that you have to actually cover up, which is kind of problematic when you export out the STL stuff. It actually figures it out, but sometimes it doesn't work too well.
Right,
So
right.
I got about 6 models I've done, dropped them into Tinkercad and worked on them.
Yeah.
And they're okay. It's just big solid objects like your whistle there, pretty good.
Yeah.
But anything with like any African, like limbs or anything like that, it doesn't scan.
Did you get the
but it's pretty good.
You got the MakerBot one?
I got the matter and form.
Okay.
MakerBot one.
The one cool thing about the Thingiverse as it applies to things that you might do with kids in classes, it gives you some really good ideas. Create some kind of storage container, or a self-watering planter. Let's try and figure out how they did that and design your own. You know what I mean? So it's got a lot of really neat ideas in it. And but a lot of this stuff that's in here, it's like, I want to create a Deadpool knife holder. It's like you need like more experience, and this one's obviously painted, and I've got all kinds of stuff going on. So a lot of them are different pieces. So like this vise, if we come in here and look at this vise, right? This is obviously not a single print. This is obviously pieces, right? So if I look over here down at prepare, I can see here's the bottom plate, here's the claw, here's the body, here's the main screw. So this is a lot of different pieces put together. And even then, it's got at least one screw in it to put it together.
Are you in the designs or in the collection?
I was in the Explore designs, and then I went to Popular. Okay, this Thingiverse is also available just on the internet. So if I were to just go into my web browser, and go into the Thingiverse, it's online as well. So if I were to find something in there, you could download it from the internet. So you don't need the MakerBot desktop software to get into the Thingiverse. But it's it is neat to print something up and then have kids kind of reverse engineer it and figure out how it works. So sometimes it can be kind of exploratory. Figure out how this works, and so you can actually turn it into an investigation or an inquiry project. where you print something up and ask them to figure out how it works. But this Thingiverse is a bit of a rabbit hole. You know, you can go down it and not come out for a little while. You know, as you find kind of cool stuff. I can't tell you how many of these little fish fossil things that I printed up as keychains. We printed them up for kids that improved on their map scores. You know, it got popular for some. They're really neat. It prints up as one model, and it articulates in all different directions. So it basically builds these little socket hinges in all throughout it, but it prints it inside of itself on a raft. It's so these are all hinges right here. These are all basically ball sockets. It's one print. You don't snap them together. It's one print. It prints on a raft, and it's
What's the same thing with the gyroscopic
right.
images that you
This here as well. This
build it inside each other?
this little no, it's not the Venus box, but this is one single print too, in that it kind of opens up, and it's all one single print. Once you peel the raft off of it, the raft is kind of what keeps it solid and still as it prints. But then once you peel that raft off, it's got some fluidity to it. Yeah, it's kind of but it's interesting to kind of ask kids like how do you think this was put together, and try and have them reverse engineer it. You know what I mean? But yeah, so there's a lot of cool things that people are making. And so just to kind of get kids fired up about making things, you know, you can kind of look at the different examples. The Frankenstein light switch plate, it kind of looks like you're firing up. But just, you know, to build a simple hinge, you know, what does that look like? What does it take to build a hinge?
You can actually make a 3D printer.
Yeah, you can 3D print a 3D printer. Yeah, this is the gyroscopic key ring. It's got 1, 2, 3, it's like 5 or 6 layers, and it's one single print, but they all kind of spin within each other. Okay, but then you kind of look at just, you know, what are some of the practical applications? This spray can holder, you know, like this is, you know, we've got a lot of spray cans in our class. We need our spray paint at the ready, right? So we you know, make a spray paint holder.
I noticed that there's all sorts of car parts that break easy, like little plastic brackets.
Sure.
To check your hood and things that hold on your gas cap and stuff like that.
Hey Mark, one of the coolest things I remember seeing from you was when I came into your class and you were doing the movie and you needed water balloons.
Right.
And you didn't have the spigot that fit. The water balloons couldn't go over the sink, so
Yeah,
the students created a little spigot that they actually screwed up into the faucet.
yeah, that's it right there.
Oh,
So
yeah, there you go.
it didn't necessarily screw in, but they were able to hold it on there and, you know, make it work. But like, and here's like if you know, have a lot of SD cards floating around, this is like a Swiss Army knife for SD cards. You know, so just kind of the neat and interesting practical applications of 3D printing. Yeah, the buckle on my suitcase broke, so here's a buckle, and maybe this one doesn't fit my suitcase, but I can actually use this one to figure out how to make one.
Right about that.
Oh, look at that, a VR headset. There you go. A sundial. Oh, it's a digital sundial.
Well, it's based on the angle of the light.
Based on the angle of the light, it prints out. It shows. See that in like kind of dot, that the digital dots there. It shines through, and man, that's wild right there. That's pretty impressive.
Put a stone next to
A heart. Look at that, a can holder. So, you know, just kind of these neat practical things. So, you know, so you can do Darth Buddha or Yoda Buddha and all these, or, you know, or you can do something that like allows you to tie your shoes quickly. Or a crossbow for pennies, which I've had many requests to print, and I won't.
Until you get home.
Right. So there's a pinwheel thing over there, and this is one of the, we printed up that pinwheel thing. Okay, brackets, you know.
Are you using other 3D software besides Tinkercad?
I've started playing around with Onshape. This is more intensive, and it's also collaborative. It is, and this is just this is new. I mean, this is the first that I've maybe I did. Let's see. Okay, there we go. So this allows you to really kind of dive in and start building actual like parts, and gives you just it's a lot more complex. So if you have kids that are just kind of beyond Tinkercad, I think this might be the next step. I'm just exploring. I don't have any kids using this yet.
Tinkercad doesn't have to custom off apps.
Right. This does. This is pretty intensive. And I know that there are kind of next levels to Tinkercad. I think one of them is called I think it's ABC CAD or something like that.
There are more advanced. And it's part of the Tinkercad family.
Yeah. Oh, ABC AutoCAD. That's the one. And that's free as well. It comes from the same it's from the same family as Tinkercad. It's kind of a level up from Autodesk. And all of these have okay, so it's 123D design, and they've got different ones here as well, like ones that you can create circuits out of. The sculpture one is an iPad app that allows you to kind of sculpt stuff. But yeah, this is the kind of next level of CAD. If you have kids that are progressing beyond Tinkercad, which I had one last year and he was using this, but he graduated, and so I don't have any kids now that are.
Well, that's when we printed last playing with.
Uh-huh. It's challenging, yeah. It's definitely a next level application.
We have one student who's probably ready to start messing around in there.
So back to the MakerBot software. So yeah, the Thingiverse is a cool thing to explore. The other place that you're going to be working in Tinkercad is this Prepare tab, and this is where you bring your designs from Tinkercad to prepare them to print on your MakerBot. Okay, so if I exported something as an STL file, I want to add that file to this to my MakerBot desktop. And so Tinkercad gives your models that you make in there weird names. So it's this ingenious hilaire.stl. And when I open it, so that's that star box, it brings it into my MakerBot work pane. And so it resembles the building plate of your printer. And so that invisible box that it puts around it, that's the amount of space you have in your printer to print. Okay? So, if I were to have a model that was that big, it wouldn't print it. Okay, so when you bring it into MakerBot, you have some different options. Over here on the left-hand side, you can move it around, which is what I do often because if you print everything in the middle, you start kind of carving up your tape. You know what I mean? So you can see I've got a bunch of divots in my tape. So when I actually print stuff, then I'll start moving things around. Instead of changing my tape, I'll move the models around until it's all chewed up. You can turn it and spin it, and this last one allows you to resize it. Okay, so those are the controls that you have. When I was talking about the printer settings, the print settings for individual models, that lives up here in settings. So we're going to take a look at it. It actually looks different now because I haven't updated this version of desktop. So I should do that real quick so that we can see what it looks like now.
Tinkercad's only web-based software.
Right. Yep.
So I know a lot of us work in institutions.
Yep.
And to get online or onto the network at an institution is probably problematic for them.
Yeah, the tough thing is like now in the Chromebook era, it's like there's no software that you can download onto a Chromebook that kids can use, and if you don't have internet access, then they can't use a web-based one. So that's a challenge.
Well, I don't see that staying the way it is very much longer. We have new leadership of probation. We'll have a meeting with him tomorrow, and he's very much forward thinking. I mean, we can't. The future is the future, and I don't see probation sticking with using stone tools forever. I agree. I mean, shit happens. I agree, and they need to realize that people are going to make mistakes and things happen. Nobody
I was
died.
gonna say, our last meeting, they said they're yank all the computers, so
They're yank.
Ron's not.
Well, and I hear what you're saying, but I'm going to go out and say that I don't think that's going to last forever, or even for a significant amount of time.
Community schools
If they're gonna do what they say they're doing, then they can't continue this, this type of, nobody's killed, nobody was injured.
I'm glad that's your threshold.
No one's killed.
Nobody died.
We get online
Nobody
access.
was injured, nothing, nobody was assaulted. They looked at, who knows, I don't even know what they did, but still.
I agree with Alex.
I felt they've been supportive, and it's the first time they're like, slow down, we'll yank all these computers. No, that's like, we say go where you are, which means.
We just don't give them access at all.
Yeah,
They tried.
probation
They tried.
makes it like,
They
they're
tried.
like at their like wit's end, and they are, I mean, daily, they're not impressed by a bar, not impressed by Go Guardian, you know what I mean? They're just like, gross looking.
And the only reason why I bring that up is obviously Thingiverse and Tinkercad have a social component to it. Share information, share ideas, share things. So as a security, that is the first thing they're gonna figure out is they're gonna go, oh, I could share this with my buddy across the way over here. Okay, check it out. That right there. is
Sure, man.
security risk.
You make a model with those letters that says something that
I mean,
right? Sure. That's
Something,
Kid-
and that's just something I just brought up because
kids
a lot
will
of
figure it
people are
out.
asking me about,
Yeah.
Can we start using Tinkercad in some of our institutions. I said, yes, if it's browser-based, well, we got to get the staff to understand that we have to get online. That's the only way this will work. Messing with this just
Yeah.
except for the community.
If there's like dedicated, like 2 dedicated computers that
That's what
have
I'm
someone sitting on them, I mean, is that an option?
I know our teachers all have access to online. So all our machines have access to the network. So if staff allows it, I mean, I'm sure they would. I don't see why they shouldn't. As long as we don't sit us in there.
Thank you.
But
Yeah.
It'll be one student at a time.
Sure.
You know.
I mean, that's, like just about everything, just like about everything else we have now is online based, and it's like, so this is yet another.
Is there any good software marketing outside Tinkercad that you use that like that other ABC?
That's at that kind of lower level. No, I haven't seen anything. I haven't seen any software out there like that. Doesn't mean there isn't any, but I mean, I found Tinkercad early. That was like the first thing I found, and it was like I didn't have to look anywhere else because it just.
Yeah,
It,
Maya's
yeah, I mean, the other one would be why am I drawing a blank right now? I hate being old. Shit, what's the one that was connected to Google and now is not? SketchUp.
Oh,
SketchUp.
I have that on.
Yeah, SketchUp would be one that, it's free, it's downloadable, so you can't use it on a Chromebook, but if you have some PCs, the kids, you can create, can easily create 3D models in SketchUp.
It's pretty simple.
Yeah. That's one that's free, and if you have a couple classroom PCs or something like that, that's something that I'm sure we could facilitate, is getting just a couple of classroom PCs that don't connect to the internet
That's
for
what
kids to
some of
create
the
SketchUp
cartoons
models.
on
Yeah,
If you're talking about wheeling the 3D printer into the classroom anyways.
yeah, have a couple of PC laptops attached to it, or Macs that that won't connect or anything, but they'll be able to use that software.
Yeah.
Yeah, I mean, but that's definitely something to investigate. We can look into some super lower level downloadable applications. So let me see if our settings look different now. Oh shit, they don't. Okay, I don't know why mine looks different. Okay, so coming in now to, oh, this is why I have mine on custom. That's why it looks different. Okay, so these are the print settings, and so this is where we go when we're looking at prototyping. And so the standard quality is 0.3 millimeters layer height and infill at 5%. So again, the infill is that honeycomb or waffle weave inside of the 3D model. And the layer height is the layer in which it spits out that plastic filament once it's melted it down. And so I can go as high as 0.4 millimeter in here, and I can go down as low as 0.05 millimeters. So that's super fine. I never go down that low. Usually I kind of stick between 0.4 and 0.2, but it defaults to 0.3. Then infill, if you're printing something, a prototype something, I go 0% infill.
What's the default on it?
The default is 5 or 10. Sorry, 10. I had mine set for something else. So yeah, 10% infill, and you can obviously jack that up until it's completely full, which would take forever to print,
And a lot of film.
and a lot of filament. Okay, so if you're using it for prototyping, then I always go for 0% and then 0.4 millimeter layer height, and that allows me to use as little filament as possible and have it take as little time as possible. Okay, and that's for just when kids are seeing did my build work? Can I test it? Can I size it? Can I look at it and make sure that this is right. So if it's for, to put it in regular printing terms, here's my first draft. Let me look at my first draft and see how that came out. Okay, here's the checkbox here for a raft. You can uncheck it, but I always use a raft. And this is the checkbox for support. So supports are what build. So if I were to build this whistle, obviously it built like that on its back. But if I were to build it this way, from the bottom up, I would need to build some supports under here, because when it started printing this, it would just be spitting filament out into thin air. Okay, and you don't want that. Although it probably wouldn't with this because it's graded. So it would build, yeah, it would build just the edge of it. But if you're building something like, let's see if I have anything over here that needs supports.
Like the student and with the switch wanted to build up the living room.
Yeah.
Kind of like fixed it, and we're like, he's probably gonna have to redesign it because we're afraid that it's floating like you said. We won't
Right.
be able to print it, but if we choose that, then the support.
If you choose a support, yeah, it will build supports underneath. So I'm gonna find something here in the.
Cut those supports off, right? Like an X-Acto knife.
Well, they're not super well. I like the one that was on there. I just peeled them off. It will leave crumbs on there. So, like I said, I have like a Dremel tool or just an X-Acto knife or something like that we kind of get all those crumbs off of there with. I know. Sorry.
So you don't design those supports, then, right?
No, they build them in their they're automatically it knows what needs supports. So like here's a good example. Like I have this little army man here. Okay, I would need to build I would need supports on this because under the gun right here, when it printed up to here, it would go back and forth, back and forth, back and forth. And when it got to here and went to print out here, it would just be spitting it out into thin air. So I would need it in order to build this. You would have supports all in here. You'd have supports all the way, all in this area right here. You would have those supports on there. It's the only way I can build it. And so, yeah, at the end of the day, you'd have to chip off all those, all in here, inside of there would all have supports. Any open space on this thing would have supports in it.
I've done, just to go on with that, I've done a little bit of experimentation on what Mark's talking about, printing it with supports. I actually called the help desk and I said, hey, I'm getting some weird anomalies for
Yeah.
stuff because it's floating. So my figure had arms sticking out like this. You would just try to print here with the space and
Right.
supports, but they suggested actually modeling a dowel.
Sure.
You know, a dowel that
Yeah.
goes down along like this to the ground. And that'll kind of it'll find it in space and actually build it from there, which actually worked really good. You don't want to have all the supports
Right.
coming off of it. It's almost just like a little piece of modeling that you put on your so it's kind of cool.
Yeah, so this is a good example of there are different ways around it. So going back into Tinkercad.
What technology do we have access to that would take a 3D image and then be able to replicate that, like to make a copy of something?
That you need that 3D scanner.
A 3D scanner.
Yeah. So I had a student that we had a science exhibition, and he was doing his he did his science exhibition on fusion energy, and so he designed this. It's called a tokamak. It's a little fusion reactor. So we kind of designed it in this space where we've got all of these parts. Okay, and it's really easy to see that the different parts, that the different geometric shapes that he may have used to create all this stuff. Then we kind of went on the idea of, do we kind of try and print it all together, right? And build it, have supports built into it, or do we kind of build it all in pieces and then glue it all together? So that's what he finally decided on, was to, to build each one of those things to be a different piece. Because ultimately, you just wanted to build a model out of it. And it came out a little messy because he used a hot glue gun. But ultimately, putting it all together. And the other thing that he had to figure out was how to kind of hold this core of this thing, into at where it is. So designed a stand, right? Design a stand that would hold it all up. And then, how to connect it so the actual middle part here has a little ring that it sits on top of that connects to the stand. And so it becomes this kind of project where not only is he creating a model of something that he's presenting on, but also kind of troubleshooting and critically thinking around how to actually create this model. You know what I mean? So it could have been something that designed and built as one piece, but ultimately, he decided on building it in pieces and then gluing it all together. And so the funny thing is that thing in the middle, it's basically a stack of magnets, right? And so the idea was that each of these things would have an indent right here, but there was a problem with the indentation. It wasn't the indentation wasn't printing right. It was because again you're going from a smaller cylinder to a bigger cylinder, and it was doing the thing where it was spitting it out. So he basically just printed it all up as one, then colored it with a silver marker, and then drew the lines around it with sharp. I mean, it's like, so it's all about kind of critically thinking, problem solving, and making it look the way he wanted to look using the tools that he had at hand. So just kind of a fun project, man.
Throw in my plumbing stuff. You could take a pipe cutter with a very sharp blade on it, and rather than
Sure.
cut all the way through, you just cut a groove and you literally measure it out and put a mark where you want, and it'll cut a perfectly round groove all the way around as long as your piece is perfectly round.
Totally, yeah.
Cut a straight, nice round groove in it, so that's another way you can do that.
Yeah, absolutely. Absolutely. So, just kind of these interesting ways to kind of figure out how to design stuff and to build projects and, really kind of helping kids work on it. So that, like this model right here, those are the rings that are around the thing. And then, this one here was trying to figure out if all that stuff would fit on the. So this one was, I think, was where he built the stand, right? So he kind of has the stand here to kind of figure out, size it up, and figure out, which way to go with it. So, the Tinkercad workspace is a cool workspace for trying to kind of like figure out how things connect together as well.
You use Illustrator yet? Export out.
I haven't done that, no.
It's pretty interesting. It's so kind of like I saw your snowflake up there.
Uh-huh.
Cut out the shape of Illustrator. Export it into
Right. So that's actually a cool thing, and what we do that. And so this is kind of an interesting way to use Tinkercad. So you can import stuff into Tinkercad. So let's one of the things that I did at the beginning of the year is on all my laptops, I got a superhero sticker for the top of each of my laptops. And so I wanted the kids to kind of look at the positive traits of the superhero and whose laptop they grabbed, and then figure out how throughout the year they could model the positive traits of that hero. And they wound up writing a paper on it. And when they were finished writing the paper, I put them in. They went into Tinkercad and designed a keychain with that superhero symbol on it. But some of them are easy to do, some of them not so easy. So we kind of this is the process that they underwent. So let's say that we do like a Batman. Find a Batman symbol image. Kind of see that. Okay, that works. I like that one. And so we, not the link. We save that image as a JPEG, and then bring it into this conversion site where you convert it to an SVG file. So check this out. So I take that JPEG into this conversion site. What's this? It's onlineconvert.com, but it's converts any image to an SVG file. So then,
The image to a 3D.
no, it's not a 3D. It's an S. It's a. Here, I'll show you what this does. So now it's converted that into an SVG file, which Tinkercad can handle. So when I come into the import area of Tinkercad and I import that SVG file, and usually the 100% scale is too big, so I break it down to about 50 at 10 millimeter height, and you import it, right? As long as it's a nice full image, you can bring that into Tinkercad, right? And then, like, if I want to create a keychain out of it, I can always, bring in a cylinder.
What does SVG stand for?
That is a damn good question.
But essentially it's just a 3D
It's just a
format.
format.
It's a format. Here, we'll look it up. It's a scalable vector graphic. Okay. Scalable vector graphic, but it's a file that Tinkercad can read, and I can drop it onto here.
Do we have that illustrated?
I can pop a torus onto it. I can grab them all. I can align them, make sure they're all aligned, and then group them. And I have now something that I can download as an STL file now, which can be read by MakerBot. I can get rid of this star box. I can add the file that is here, and now I can just print up my superhero keychain. So, it's something that can be done pretty quickly. Right? And so you're looking for ways to engage kids, and having them actually create something that they can, clip on their backpack and is always there as like a reminder of whatever it is you're trying to work with them. So that keychain now, like if I see it on their backpack and they're acting like an ass in class, I can say, WWBMD, what would Batman do? You wrote a paper on the positive traits of Batman. You're trying to, you're about justice and you're not about hurt. Come on, man. Let's reshape your thinking here. So it's gonna be this cool kind of this reminder or whatever, however you want to use it, right? But it's like, it doesn't have to be, super connected and super involved. It could be something that takes 5 minutes to create and then, a half an hour to print, and you're out a half an hour of zit time and just a spot of filament, and you've got a keepsake for a kid, right? So yeah, it's pretty cool. So yeah, those settings are super available to you. So something like this would not need any support because there's nowhere in here that it's building on nothing. You would think that for something like this, you wouldn't need a raft because it's just a big flat surface, but I print everything with a raft because this flat surface, the way that the printer builds that raft, it builds it so that it is guaranteed to stick to that surface. Whereas the back of this thing is just a flat, slick surface. That raft is zigzagged and cross-hatched, and it's a surface on which it can build anything. So you might think like I want to save filament, so I'm not going to build that raft. But and trust me, I did that, and I wound up with a lot of crap, just crap builds that I had to stop halfway through because it had printed halfway and then dislodged from the build plate, and now it's screwed.
Does Tinkercad, like, will it, make sure that it's flat? Or one of the problems we had is that once we create the was that they could just get it slightly skewed.
Yeah, as long as in Tinkercad you are flush with the work plane. See, in this case, I can hover over this arrow, and I can see. Well, you can't see over there, but you can see here that it's 0.00 millimeters. It means it's flush with the work plane. Okay, and if it's like there at 0.83, now it's hovering, and it'll read that way when you bring it over to MakerBot. So you have 0.8 millimeters of open space underneath that print, and so yeah, it's not going to like that. So you just have to make sure that you are flush with the work plane.
If you were to punch out the Batman symbol and drop it into MakerBot to have it hollow, basically, would you still put the wrap on there as well?
I would.
You would?
Yeah. Yep. I just, you know what? I file it under better safe than sorry. You know what I mean? It's like, I know that there are some prints that we get from the Thingiverse and it says no RAF needed, and I'm like, bull crap. I've had it happen over, it took me like 5 or 6 times for just to say, you know what, no more. Because you'll be in the middle of like a 3-hour build, and at the beginning of hour 2 it just pops off, and you're just like, it's just too frustrating.
I saw in the printer settings, there's a temperature. Do you ever have to mess with that?
Nope, I never mess with it. It's the temperature is 215 degrees, and I don't mess with it. It just works.
You prefer clear unfilling, solid filling?
No, you know what? It just looks. Yeah. So there's some frustrating thing there. So just getting into some frustrations about the printer itself. So some filament is like thicker than other filament. So I found that the thinner filament works better. But it's all made. But I've never used a third-party filament, but there's a bunch out there. But I found that the thinner it is, the better the extruder will accept it. Like the one I have in here now is a thicker filament. It's like this one is like a translucent blue. But and when you pull out filament, the tip of it is kind of melty, so it's like a little ball on the end of it. So before you put it in there, you snap it off. It usually snaps. So right next to my printer, I've got like 500.
So you do get MakerBot filament.
I do, yeah.
And it comes with that spool.
I do because it snaps in. It snaps in and fits right into the back of the printer.
So it comes with that spool if you throw the old spool away.
Or I keep mine for like prototyping stuff.
Okay.
I don't throw a whole lot out. So
I'm just saying, you don't need it for the MakerBot anymore. You don't have to
you don't like refill it.
rewind it or
No,
anything.
yeah, it's not like a fishing reel. You don't get it respun with new filament. It comes on the thing here. But you just want to make sure that when you put in filament, that you're putting it in with a fresh break, or you can cut it too with some clippers or something, or scissors. But one thing that will happen, especially with these bigger spools, is that when they were put on, it got somewhere. It can get caught up under previous filament, the filament that was already spun in there, and so you'll start hearing as it's printing this like it's groaning in there, and then all of a sudden it'll say filament jam. because it's having to like really tug to get the filament out of there, and that can be frustrating. And there's kind of what I'll do is, you know, as awesome as it sounds, is I'll unspool it all by hand and I'll spool it back on. Depends on how much is on there. If I have kids that need community service hours, no, I'm serious, man. That's you have them. I want you to sit here and unspool it and then spool it all back. And, you know, I'll give you double hours for that, man. Whatever you need, right? Make it work.
I know you said you ordered the maker, but filament that have you used
I have
with MakerBot, because we got for the old Tinkercad
Yeah.
we ordered a bunch of filament that all came third party from
Yeah.
them. So I have like,
And it doesn't. It won't fit in. It's a different.
it is a different.
So what I would do with that, and you can even find, you can either have kids make it, or you can find the model in the Thingiverse of a spool, right? So you can just have a spool sitting on the side over here and have it feeding into there, and it'll just roll on the spool.
So in theory, that third party filament should work.
Oh yeah, it's supposed to.
Or after you use your old carrier, whatever you want to call that thing, re-spool it on that one and then have her use that again.
Yeah.
Just make sure you don't tighten too much.
Okay, so right now, I was going to show you over there, and then we got onto that. But right now, it is. I am taking the filament out, and so it had to heat it up first, and then you have to kind of give it, and then it gives you the unloading complete, so you can now remove it. You can see the end of it is, you know, kind of, it's kind of furry, so if I ever used it, I would just kind of snap that end off of it. But this, pop it up, kind of unspool the filament from, so you can see that this stuff is a lot thicker than this stuff. And you can get out, you don't have to sit down.
Does it make a difference? The extruder knows, it's just a matter of just getting the stuff, right? Whether the filament's thick or thin, it doesn't make any difference.
Right, it can get, like I said, it can get grumpy with the thicker filament when you're feeding it, when you're actually loading the filament in. So when you snap in a new roll, you can just feed it in manually. Push that guy back down, and then you set it to load. And since it was already heated up for me unloading it, you just kind of push it through the top, and you can feel it pulling. It'll just pull it automatically. You're not supposed to have to force it in, and then you just kind of wait until it starts spitting out the filament. It'll clear out so the first bunch of that stuff was clear because it was clearing out what was left from the old one. And once you know it's pushing it through, you give that, and you kind of pull that out, so it gives you that little bit, and then it's ready to print in red now. And you know, just kind of set it to. Only one color at one time. You can, if you want it to be kind of a two-tone thing, you can pause it in the middle of printing, put it a different color, and have it print up from there. So, you know, you can do that.
Are you supposed to have some type of like ventilation or anything?
No.
No.
Nope. The only thing that gets hot is the extruder. Don't touch the extruder. Okay?
Plastic's that
Don't
hot?
lick the extruder.
Like right now? Huh?
The plastic cools really quickly. It cools right.
Yeah, I mean it cools as it comes out. Like I could just have it spit it right out in my hand, and it would cool as it hit my hand. But understand, like this thing, especially right here, this metal part is 450 degrees. It will burn the shit out of you. Okay? Yeah. So like in the middle of a build or something like that, you're like, oh, okay, my extruder because what can happen sometimes, especially when your filament gets like I said, it gets underneath the other filament, and it starts pulling away. It will pull the extruder because the extruder is held on by a magnet. It will pull the extruder away from away from the build arm here, and you'll have an extruder error, and it'll say you have to reset your extruder. You reach down there to kind of mess around with the extruder, and you're touching 450-degree metal, and shit, okay? And you know, it takes once. It takes once. Yeah. And then you're like, okay, I'm not touching that thing until it's cooled down. Good news is it cools down pretty quickly, but still, it's super hot. So you know, you want to make sure that it's completely cooled down before you pull it off. You know, there's a couple things about the extruder that if you're having problems with it, you can do before you take it apart. Is you can this top, if you have an older extruder, which all these have, one of the new ones, you can kind of this top part here, you can pull that off, and the hole, it has the holes right there, so you can you know, you can eyeball that a little bit. Also, there's a little lever here on the side. So that little lever, and that little lever loosens the element inside that grabs it and pulls it. So if you're trying to push some filament through it, you can push that lever down, and that kind of eases up on what's inside of it. Maybe that'll help push your stuff through it. But you know, honestly, I've manhandled with a pair of pliers, just jamming filament into it to try and push it through, and it's worked. You know, I mean, short of taking it apart, which you know voids whatever warranty you have, but it's super easy to take apart too. You know, you just pull these little clips and pry it apart. It's got clips on both sides, and start looking inside of it. And you know, it's not a very, very complicated machine inside. You know, ultimately, I figured, you know, I couldn't make it work without taking it apart. So what could it hurt to take it apart? So I took it apart, and it worked for a little while longer. And then I took it apart again, it didn't work anymore. So then I said, okay, I got to order a new one. And then, well, I'm ordering one. Why don't I order two so that I have two? And then when I got both of them, one of them didn't work at all. So I had to, you know, it's like.
I just ordered 5.
No, that was a more modern function. Those were the best. And this is a CTE machine, right? Those are CTE functions. So
Some of them are, although Joanne purchased, I think, the old one for,
but wouldn't like filament and extruders be covered under CTE?
well, first we'd like to get Joanne and Nate to pay for it, but if not, we'll pay for it.
All right.
Ask your principal first.
Yeah, I mean, ultimately, the stuff that you do with your 3D printers is like a crown and a feather in a cap of CTE. So if you get stuff from CTE, say, yeah, man, so we're using our, you know, right? It's all, you know, this all happened because of Alex.
Well, that's not true there, but what I would like to see is yesterday we had our first kind of tutoria exhibition, and for those of you who do know what tutoria is great. But what I'd like to see here is everybody that's here for this training, you know, obviously you're only going to learn a little bit here. Mostly you need to go back and mess with it and play with it and experiment and fail and try again and fail and try again. And what I'd like to see in the future is rather than having one of these kind of traditional trainings, because I don't know if everybody saw the list, there's like 60 people that are interested in getting training, and I think that's great. But what I'd really like to see is that each of us here, as we learn more, then we go to you know, our regions, our sites, our networks, whatever the hell you want to call them, and you know, teach others how to use it rather than have a centrally located one training. So that's kind of my vision, or you know, momentum learning vision about how we want to pass on some of this information.
I think that's a great idea. Like, for instance, at Kearney, when would that take place?
It won't be till next school year sometime, and you know,
No, I mean, like, when in the day would you have?
that's something you have to work out with Joanne, and maybe you do that on your
maybe
Thursdays
Teresa and I
or
could
something
show
like
some
that,
stuff.
right? Or maybe there is a day that, you know, I don't know, that
Seems like
remains to be
there
seen
should be
yet, but I'm
an
sure we
evolving
can figure
time.
this out.
I mean, I got mine in November, and we screwed around with the classroom for a couple of months, and then I took it home over Christmas break, and I just did all kinds of stuff with it. And when I came back, and I was like, all right, now we're ready to boogie. You know, I just needed some extended time with it. You know, like take it home.
Well, and I'll be honest with you, I took that one home when somebody wanted to use it, I was like, well, I want to mess with it. I took it home and I messed with it for over the weekend, and so I'm not going to tell you you can't take it home. I'm going to encourage you to take it home and use it and mess with it and play with it. Because the more you play with it, the more comfortable you're going to be, more comfortable you're going to be with your students. Students are going to get comfortable. Also, what I'd love to see is some kind of JCCS, momentum-wide, contest where student design, where it's got to be 100% student design and built, and then interesting, fun, crazy stuff, and some kind of contest. Maybe we could have lots of different categories, but where we all get together and we show what we've done, and then kind of tutorial style. How do we do it? What do we learn? How do we learn it? What mistakes do we make? What struggles did we have? How do we overcome those struggles? And I think that would be a lot of fun. This simple little thing right here. 90% of JCS kids would love to do something like that.
My kids got excited with the samples. They were beyond excited.
Mark, what has your experience been with the glow-in-the-dark film?
It's cool. This is what this is made out of. These two things are made out of glow-in-the-dark film right here. So, yeah. That was more expensive. But, twice as expensive as the other stuff.
And Steve and anybody else here, if I would encourage you first to go talk to your administrator about, hey, I have this information now. I'd like to pass it on to other teachers within my network. Encourage, work with them. And if you can't get anywhere with them, contact me, and I'll go straight to Stacy. We have to figure something out. We can figure it out, because the reality is I know everybody wants these things working, being used, students working with them. It's the right thing to do.
Well, it just embraces the entire ideology that we are supposed to be.
Right.
That administration says that they want us bringing to the forefront, which is inquiry-based learning and deep dives into understanding how things work and building things that will connect with different types of learning. And unless you can bust out a hammer and nails and a skill saw and a chop saw and all that stuff to actually build stuff with your hands, this is the next best thing. And it's also great for doing like smaller prototypes of bigger things.
I'm gonna be honest, all I heard is blah 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 blah
Momentum Learning does neither endorse nor support the views of Alex Wong. So
if you couch it in the terms that's going to help me work better come Monday morning with my students, what can they say?
Oh yeah, and
I actually think you're right. I don't think
and
they're
you know what? Seriously,
I see what you're saying.
the policy always. Just make your policy. You ask for forgiveness. It's like, sorry, shit. I'm just trying to make this better for my kids. You can't fault me for that.
Just don't leave it in your car.
Don't get it stolen.
Straight home.
Mark, do these come, because we haven't even opened the box, anything said, do they have filament already?
Yes.
It comes with a large spool of white filament. That's kind of like, and so for the longest time until I ran out of that, that was my like scratch paper. Because the white filament doesn't look really good, it doesn't, and I don't know if it's lower grade filament that it comes with, but it just doesn't print. Is that what you have in here?
Yeah.
No, you have clear.
Yeah, that one came with clear.
Oh, it came with clear?
Yeah, I pulled it out of the box.
Oh no, this actually. This is
They
different.
paint really nicely too. Like they paint really nicely.
Okay.
We'll have our students create stuff and then they'll actually paint them as well. And then
That's great. Hey, Mark, the MakerBot software that you're on, you just go on the internet.
Yeah, it's just a down. There's a link on the site that I created. There's a link to it on there.
Can you tell us the site of that name again?
It's bit.ly/momentum maker.
And when we order the filament, could be a weird question, but which one of those forms do we use? Is it supplemental material?
It's the yeah.
Supplemental,
Okay.
yeah. To be honest, I don't even know number of shells. I don't know what that means. It's on 2 and I just leave it on 2 and it works.
You can always call desk help for MakerBot, and they're really helpful with a lot of questions that you guys probably ask about it. And I've done it myself. Mark's done a great job of like connecting people to a lot of that stuff. If you call them, you're stuck like in the middle of the print, maybe this and that. Like they would answer the questions right away. Just go step by step. Like stuff talk about jams and stuff, and all that. So it really helpful.
Kind of, for those of you who don't have any idea what tutoria is part of the responsibility of tutoria is when you're the student or the tutee, you understand while you're learning that one of your responsibilities is then to go out and be the tutor, be the teacher. And so don't be surprised when I contact you sometime next school year, not anytime real soon. I'm going to give you lots of time to mess around and play with it and say, hey, I'd like to set up a training where you can train everybody else at your region or your network or something. So what I think that does is that it kind of builds in responsibility on everybody's part that, okay, this is serious, I'm part of this. Not only am I going to learn about this, my next job is then to teach other people about it. And I think we want to pass that on to our students. And like I said, we had our first tutoria expedition yesterday, and I feel like it was a success. We have a lot to work on. We have a lot of things I think we can do better. But I think if we can kind of do this as a staff as well, I really think it brings a lot to what we're doing.
Well, that's kind of the main reason that I put just a web page together. That I think that sitting around and waiting for momentum to happen from momentum is frustrating. So we have to kind of create our own, and so things that we could create and build and share with each other is the best way to do it. I'm not going to wait for the Momentum Learning webpage to come out so we can add stuff to that. It's like, just build one and connect to it. And if you do something cool in your classroom, send it over and I'll put it on there and we'll just share that stuff together. That's just the best way to do it.
I would like to propose us to start thinking about something that we could do together. So like there's some pretty complex builds that require a lot of different parts. So that we could, as a team, I mean, you could even make a robot. They have a robot that you could actually part by, and it's hundreds of parts. So it'd be fun to be able to come together and have a group of students come in to assemble parts that were assembled by another teacher.
That's real.
So I do have a plan.
Sorry, I can't stop. I can't stop with momentum.
Like a big mouth.
Can't stop.
You know
I do
what?
have a plan for all of us to get back together at least for another half day type thing where, once you've messed with it, once you have some experience, and then you realize what you don't know and what you really need to know to kind of move to the next step. I think that's what the next training is for.
I know I asked Dave.
We don't have any problem with bringing students at all. That's fine. I think oftentimes students add a certain dimension to it that is really positive, really. So what I'd like to do is you guys mess with it over the summer, or when you come back, take it home over the summer. I don't know. I'm not going to tell you take it home over the summer, but mess with it, and I'll be in contact next year, and we'll do a follow-up training, and hopefully everybody will have done quite a bit of experimenting, messing around. Maybe you can use it in your class. I know some of you are working over Intercession want to do this. I think that's great. But have a follow-up training, and then once we've had that follow-up training, okay, now what do we as a group do here? How do we take it to the rest of Momentum Learning and get more people involved? And I literally had people like the food service workers say they're interested. That makes me think I won't be using the JCS distribution list anymore. But anyway, I don't think that's a bad idea either. If they can get passionate and want to do something, that's great.
You can print up some bread that'll taste better than yours.
There's I read something about electronic medical fields as printing medication.
There's all kinds of
filament could actually print out those bills.
I can't help but think I read.
I got a spool of OxyContin in my car.
Well, I really think 3D printing is a way of the future for so many things. If you just need it, you just print it up at home.
Yoda.
Because all it is stuff and software, and the stuff is the spool of stuff, and so much stuff can be made. So many of these things we use every day, all the day, are just made out of plastic stuff, and you don't have to go buy it, you just print it up.
This is, I mean, one of my favorite examples is my doorstop was stolen or disappeared. And so I was like, oh, damn, I need a doorstop. And the kid said, let's just print one up. And I said, well, figure it out. And we had a competition, and the dead guy doorstop's the one that won. So, but that was, this is like 5 prototypes later. The first one was too shallow, the door went right over it. It was like, so,
Trial and error.
yeah. So it's, it's just like that kind of stuff, This is a cool little example here. This little, there are 2 shelf brackets that you slide pencils through to make a little pencil shelf.
Steve, I know you're thinking about doing the wind thing where you make electricity with wind power.
Right.
And I love the idea of prototyping blades
Right.
for your fan. And there's so many different ways you can build these blades to see what is the most efficient way to harness that energy, that wind energy, and turn it into electrical energy. And this is a perfect machine to do it.
Just know that your kids are going to want to print guns and knives.
Yeah.
That's an
Yeah.
instant. Just,
I was thinking of a 420 keychain too.
There's going to be 420 keychains and weed leaves and all that good stuff, right? And the cool thing is that it's not just like something discrete that just kind of can happen on the sidelines. It's all going through your computer, or it's not like they can just kind of sneak that stuff through. But yeah, weed leaf keychain has been offered up. Yeah, they will try. And just cool practical stuff like this is not the best model ever, but it's like I need something to kind of keep these the spools of things. So right next to the printer, we got a few of these things with our spools on it, and made it with holes in them. So we bolt them together, and so it's just a little rack for our filament. And so it's you just kind of offer up. Anytime a kid says like, can we do this? I'm like, I don't know. Can you? Like, figure it out. If they can, great. It's that whole idea of failing and failing and failing and trying and trying. You just gotta. This is a great tool to be able to instill that in your kids.
Well, and what I really love is you have the physical representation of the failure too, so
Right.
you can see it go from a piece of crap
Why didn't it work?
the first time
Right.
to the 5th time you actually got a useful object, and you can see that progression through all the different prototypes.
Yeah, I was talking to Cheryl Winchester. She wanted to be here, but she couldn't. She's using a lot of what I was using it for. And they did she had an assignment recently where they were creating wheelchair ramps, like designs for wheelchair ramps, and prototyping those, and she's doing like tessellations, and things like that, and printing those out. So she's looking at all kinds of different ways that it can be applicable to some of the mathematics we're looking to do. I know she was talking about some kind of like mathematics in 3D printing competitions, like the bridge building competitions, stuff like that. So,
And you don't know she is the new math impact teacher, so she's going to be a resource for all of you to do math, but then also bring in this 3D printing technology and experience as well. I think that's great.
mhm.
Are you a tech teacher, English teacher, history teacher? What?
I'm like, if you need someone to do something, I'm that guy. I teaching English. I'm teaching residential and commercial construction. I'm doing like a tinkering elective, like just whatever. Officially, I'm the CTE teacher there. So that's
The day I was there, on purpose.
we're doing like a video where I sprayed hairspray all in my hand and lit it on fire for a video.
Great job.
All right, there you go.
So how about next year? Are you going to be full-time teaching?
Doing one English class. I'm doing two commercial and residential construction intro to, and then doing a video game design. That's the plan. Yeah, that'll be fun. Like doing a full-on residential commercial construction curriculum where we're going to build foundation, frame, electrical, that we're doing it from right from the standards and just going step by step through it. Do that.
Hey, should we hire?
Well, I'm thinking of incorporating it in a kind of a tiny house project.
Now, believe it or not, I was at the San Diego Workforce Partnership and we do want some type of renovation. Job Corps, they are looking for I'm not going to guarantee you that they're going to do your house. They put all that. You got to supply material. I don't know how many they schedule a year or what.
3D graphics happen if they're really interested. like, or if anyone has a bunch of goats. So, any other questions, thoughts, ideas? I mean, when we were talking about a full day, it was really kind of getting into the design and Tinkercad and playing around with that for an extended amount of time. I mean, we have, what time do we have the room till?
We have it all.
What time would you envision starting off?
What time does it start at 12:30 down there?
The
Down around noon. It's about an hour.
good thing that the dunk tank was permits, I bet.
Hey Mark, do you have a link to that website that converts it from JPEG?
Yeah, I'll put that on the resource page.
Right.
Did you have, I can't upload something like Thingiverse? Did you have something built for just JCCS that you could upload
Your designs?
Yeah.
I don't, but that's easily done.
Oh, okay. Oh, I thought you said you had.
No. Yes. Well, and I think it would be cool also, Alex. I don't know, but I think just getting teachers, even if they don't have 3D printers, to have their students to start using Tinkercad.
Yeah.
To basically just to understand three-dimensional design and to start playing around with that. And then, like if they design things and they, want to print it, then we do have those printers out there. You know what I mean? It's like.
Well, and also I'm trying to envision a few printers that are either here or at our CTE office that if you want to check it out for a week or two, you can kind of come check it out and print some stuff out and then bring it back. And
Or shit, you just go to the downtown library on the 8th floor. They got like 9 of these things.
So really, all you need is like your flash drive.
Yep, all you need is the file. Yeah.
Is it free to print something?
Free to print.
Really?
You just have to stay there with it while it
Are they
prints.
MakerBots?
Yep, they're the same ones as these.
Oh, okay. Cool. So I'll try to get that information out.
Yep, the big downtown library has a crap load of them. So that image converter, Ron, if you want to, there's a link to it on this page now. Right there. So the image converter, if you want to convert images to SVG, it's that link's right there.
Oh, perfect. That's it. So much. That makes it so much better.
So and we can definitely start doing that. I mean, like if we want to start building like our own Thingiverse. You know what I mean? We can definitely build that, you know, like if your kids create something awesome, just send me the file and, you know, we can create our own little repository of cool designs, you know? Yeah, it'll be a portfolio of 3D designs.
Of the momentum portfolio.
Right. So I guess the rest of the time would be spent just playing around in Tinkercad. If you have any questions while you're playing around in it, or to just kind of connect with each other on different ways to use it.
So from there, if you did
What do you mean sync the apps? Six different apps. On the MakerBot site? Oh yeah, those are actually one component. Yeah, those are all. You don't need any of those to start. That's all you can be on me. Like I don't even use that kind of stuff. What is that? Oh, okay. Yeah, with something like that, that's most likely, like the way that I did the Batman thing, they found that image and brought it in and had it re-represented. You know what I mean?
So what we're doing is just straight print something. Where would you go to something else, Tinkercad and do the box?
Sure.
Is that
We have
simple?
less than
Well,
one.
I mean, no, it's
Less than one.
I always have to start with it's like if they're into it, they'll know it. If they're not into it, they're just like, oh, whatever. Yeah, I'm like, right. Totally. Yeah, you can have it change. I mean, like that, and that, like that. Just bring in that file, and you can have. I feel like the best music is it's like it's super easy, super quick. It's like it's something that at this point in the game, I don't even show them how to do it. I have no idea. You know what I mean? Like, and it's for if I was in a situation where I had only had 50 days and I had this as a resource, that's like
I do. I have it. We've run it a couple of times, but we've only used
so
it just to.
like
I have them. I have everything, but I just
whoever
I haven't been able to.
you, it's like yeah. It's like you want to say like I only have a kid for 3 days, so I'm gonna have to read something maybe like ignite the spark of reading. Well, come on, or ignite. But this is something that legitimately can be like, this is cool. I'm gonna do this, and that's something that I don't remember. You'll remember. I can access Tinkercad wherever. I can do stuff wherever. Yes, and so it's like super high impact. It's like, yeah.
All right.
I know, right? Yeah, usually I'll do that like on that like on a keychain where you have the base and you have it. You have the letters are raised, then you do it like as the letters are raised, and if there's like 10 minutes left or whatever, or it's at 90%, then I change it out, and then you get the very top of it is a different color and it pops. That's right. Hey, so Mark just asked a good question. This is just an add-on. Is that like when kids are making keychains or something like that? What really makes it pop is if if the letters are raised, right? So you have your background. Let's say your background's clear or white or red or whatever it is. The best spool that I always make sure I have on hand is black, because if it prints in whatever color it is, you pause it at like 90%, and then you put black in, and then it finishes it off in black. So just the letters pop in black off of whatever the background is. It looks really cool. Or you can imagine like that Batman keychain. The back of it's like a yellow or something like that, and then you have the top of it, the features of it in black. It looks pretty cool. That's been the best use that I've had with kind of two-tone or doing a second color. Yeah, you pause it, and then it doesn't. It usually doesn't. Only when Alex touches it. But yeah, when you pause it, it'll have a down on the bottom button. It'll have like, or see to the bottom or the top. It'll have a little hamburger, the 3 lines, that it's in Google Chrome and all that. You press that, and it'll give you a list of different things you can do, and one of them is change filament. And so you can just change the filament out. And you have to, it's already hot because it's been printing. So you just unload that filament, and then you load another one, and I've never had a problem.
Now, Mark, can you change it at a specific point, like say, okay, you hit the letters, pause, and then I want to change it.
You have to eyeball it. There's no alarm that goes off. So yeah, usually I wait till like about 90%. It's done, and then you just switch it out. So part of those raised letters will be the original color, but on the top of those raised letters,
I see what you're saying. Yeah.
Oh, so they were kind of at a tilt.
Yeah, the one that was
Standing straight up.
Oh, yeah, a while back. Yeah.
Classic ass kissing you never star. Way to go. You just guaranteed yourself carte blanche, man. No, it was a J thing? You didn't get me that low?
No.
So it's going good.
That's such a nightmare.
Fun.
Not my nightmare, but
Yeah,
a
fun.
nightmare.
I wish I could figure out how to make it a job.
Well, it's not typically ours either.
I'm sure you can.
Right, yeah, I don't.